Welcome to the amazing world of physics. It is time to learn about Newton's laws. Sit back, relax, and enjoy this once-in-a-lifetime educational extravaganza. We will begin with Newton's first law. The first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In the setting of a vacuum, such as space, an object's inertia, the tendency of said object not to accelerate, will remain unless there is another force. In a more realistic setting, this can be shown by pushing a chair off a desk. Of course, if you have access to sciencey resources, you can accomplish this in extraordinarily entertaining ways. We will now move on to Newton's second law. This law states that the acceleration of an object is directly proportional to the net force acting on the object, and is inversely proportional to the object's mass. To show this, we will use the equation F equals ma, in the context of various story problem. Question 1. If an asteroid is heading towards Earth at 50,000 meters per second with a mass of 2 trillion kilograms, what is its net force? The answer is 100 quadrillion newtons. Did you get it right? Question 2. When the guillotine's blade is dropped at 9.81 meters per second and lands with a net force of 392.4 newtons, what is the mass of the blade? The answer is 40 newtons. I know you got that one right. Now it's time for the final question. A person punches an elbow with a force of 2,500 newtons. The mass of his hand was 0.52 kilograms. What was the acceleration of his fist? Good job. The answer 4,807.69 meters per second. I knew you could do it. Finally, we have Newton's third law. The third law states that for every action,
and the final ingredient?
there is an equal and opposite reaction. In this first example, we can see the fuel igniting, which creates a force which sends the rocket upwards into the sky. In this second example, we can see that being a bully is also a form of physics. By pushing the unsuspecting victim to the ground, the force exerted causes the opposite reaction of the poor child falling to the ground. In this final example, we see this poor fellow getting hit in the face with a ball. The force of getting hit in the face causes his nose to bend like rubber, and his face to plasticize. Isn't it neato?
Oh, it's a clean hit on the side of the face. Oh, the shockwaves. Oh, your nose bone moved under your nose. Oh.
That's it for this episode of the amazing world of physics. If you liked this video, do us a favor and smash that like button. If we get 5 trillion likes, we will upload another. See you all next time for another amazing learning experience.